Okay, so here's my first rocket stove. This one was built using 3" by 3" square steel tubing, and it uses a 90-degree angle. The feed tube and the burner tube are the same size. I set it up on some angle iron to keep it off of the surface that I'm burning on. That helps keep things cool. And the angle iron out the front here has a bit of a shelf so that I can feed wood in and it won't fall out. This was an add-on. First time I built this, I just had the L tube with some feet on it, and I found that the bottom part of the L was short enough that the pieces of wood that I was putting in, the sticks, were actually falling out as they were burning back. This is not a good idea. That's why I put a piece of angle iron along the front, just as a table, a mantle, to help hold the wood as it burns back, so that it doesn't fall out. So at the top of the burner tube, I put 4 pieces of 3" by 3" square tubing, 1 inch thick. This creates a plate that I can set a teapot onto, and this allows the heat to come up and out and around without blocking things off. I found that this is just the right size for boiling a teapot. I can boil a teapot with a fistful of kindling and have tea for 2 or 3 or 4 people in about 4 minutes. There are some problems here that I want to solve. First, as long as I'm just boiling tea, I have to feed this thing manually. I don't want to do that anymore. So I want to angle this up and make it a little bit longer to hold larger pieces that will go in and will fall in instead of out. I will have to spend less time feeding and less time babysitting the thing while it's running. Second, I've also found that while I'm feeding this, at the end of a burn, I've got a whole bunch of ash and stuff building up right down here. Eventually, that blocks off the feed tube in the burn chamber so that it doesn't work anymore. It has to be cleaned out. As long as I'm just doing tea, this fills up a little bit. When the tea's done, the fire's out. Next time, before I boil some more tea, I just empty this out, empty out the cold ash, and do it again. But if I'm going to go bigger, I need to have something that allows me continuous clean out without putting out the fire. I'm going to do that by putting in a plate about 1/4 of the way up that allows air in the bottom, and I can feed fuel in the top. At the back will be a steel mesh that allows the air to come up, and the fire will stay above the air. Also, by going a little bigger, that's going to allow me to cook bigger things, like maybe aluminum. We'll see. I cut a 45-degree angle across a square tubing, fitting one piece and welding them together to make a 90-degree angle. For the Mark II, I want the feed tube at a 30-degree angle. I can still make the same cut, but I need to figure out the angle and the measurements. Here's the chimney tube. Here's the feed tube. The feed tube is at a 30-degree angle up from the floor. The angle between the chimney tube and the feed tube is 60 degrees instead of 90. This means the cuts for the chimney and feed tubes need to be 30 degrees instead of 45. How do we calculate where to cut? I want the feed tube to be 6 inches long. The feed tube is 6 inches by 6 inches square. We now have a triangle with a known angle and one known side length. The length we know is opposite the known angle. We don't know the adjacent or the hypotenuse lines. Remember your trigonometry? SOHCAHTOA? We're going to use sine equals opposite over hypotenuse to calculate the length of the longest line. Here's a neato trick. If we write the equation as sine of 30 over 1 equals opposite over hypotenuse, then change the equals sign to a multiplier and treat the fraction bar as a divide by operation, we can cover the part that we want to solve for and follow the equation around. Thus, to find out the hypotenuse, the equation is 1 divided by sine of 30 times 6, which reduces to 1 divided by 0.5 times 6, which equals 12. We now know the hypotenuse is 12 inches, so all I have to do for layout is to mark a line 6 inches in from the end of the tube and adjust my square to measure 12 inches to the other side of the tube. I now have a 30-degree angle.
See that? Burnt brushes. This is a 2-saw job. Now there's a neat old little trick that you can use if you are using a saw like this to cut a line here. You won't necessarily be able to see the line that you're cutting while you're running your saw, but you can see the edge of your saw. So what you do is, once you've got the blade lined up with your line, you put a mark on your steel, draw that line all the way across, and now you've got a line that you can follow while you're cutting.
Like a 3-saw job. Saw job. There! I should have started with this one. We've got a 60-degree angle here. It worked. Now there's still some fit-up issues here that have to be dealt with. We'll deal with those in a moment. Before we do, we are going to add in the air tray, the air channel. We're going to put in some 1x1 angle iron on each side, run it down the inside, and on top of that is going to lay this. Let's calculate the length of the legs. This is the front view. This is the feed tube opening. This is the side view. I want to mount 4 legs at a 30-degree angle out. The measurement from the top of the feed tube to the feed tube and chimney corner is 13.5 inches. Let's call it 14. I want 2 inches of clearance at the floor, so the distance from the top of the feed tube to the floor is 16 inches. The legs will be removable rebar fitting into square posts at the top of the feed tube and an equal height from the chimney tube. This makes the rocket stove easier to move and store. So how long do the legs have to be if we angle them out 30 degrees? We can use the sine equals opposite over hypotenuse formula to find the length of the legs. The sine of 60 degrees is 0.866. We can work it out the same way we did the chimney and feed tube calculation. To solve for the hypotenuse, we turn the equal sign into a multiplier, the fraction separator line into a divide by, and follow the formula around. 1 divided by 0.866 times 16. So 1 divided by 0.866 is 1.15 times 16 gives us 18.4 inches. Let's call it 18.5, maybe even 19 inches. Now I know how long I need to make the legs.